Hello everyone, and welcome to my channel again. So we are right now at the base of Cheyenne Mountain, which is, if it's that way, but more specifically we are in an area called Cheyenne Canyon, which is a canyon that was formed here over millions of years after a major uplift of the Rocky Mountains. And this area specifically sits on the base of the eastern side of the Rocky Mountain slope. And so about 65-70 million years ago, excuse me, an uplift occurred in the middle of a basically an inland sea where there was lots of marine life. So around here in this canyon, we'll probably see some fossils. But also note there's lots of granite, and there's three different kinds of material. You have the granite, mica, and some feldspars, and there's a unique mineral called Manzanite, which is a type of it's a quartz and a feldspar, very unique to this area. So but yeah, let's do some exploring. Let's see what we can find. I hope this is going to be a fun-filled video full of all kinds of discoveries. Let's get to it. So this is North Cheyenne Creek, and this is the creek primarily responsible for helping to carve out this canyon, along with eons of weathering and erosion from glacial freezing and thawing. Many of the rocks in this area have undergone extensive cracking and yeah, so we'll probably come across that here up the valley here, or canyon, not valley. So this is kind of a look at the trail we're hiking here. Pretty nice day. It's I thought it might be a little colder than usual, but we're having a slightly warmer winter here in Colorado. Same in Kansas, I guess. Pardon for the wind, but as you can see ahead of me, there's that big mountain there. So there's a lot of mixture of sandstone and granite in this vicinity. But as you can see on the ground, there's plenty of big boulders that have fallen from the cliffside. So, which trail should we go on? Well, I think at the left, because it might lean closer to the canyon. It's a beautiful, beautiful scenery. There's some people up ahead, so I'm going to stop and I'll resume when there's no people. As you can see, the product of glacial weathering and joining this rock wall here is literally coming apart. Very cool. We're a bit up the canyon now. Not too far, but getting in the vertical zone. So you see the granite outcroppings are quite prominent as you go up the slope, and that's to be expected as you climb up a mountain. And look up here, we got a massive formation here. You can see joints in the rock there. Let's take a close look. You look at here. There's a big joint right here. You always wonder if this could fall on you. Hope not. All those joints. Very cool. Here's more of the creek. And I decided to take a stop here. You can see, even on the smaller scale, the joints occur in a similar pattern as you saw in the previous clip. Horizontal joints. Many of the rocks here contain biotite, which is a black mica. and black micas have a basal cleavage. Not sure if that's contributing to the horizontal joining in some of these rocks. So you have a mixture of quartz and mica and some feldspars in there. Very interesting. We're getting towards the oh, there's a road up here ahead. Now the reason why I stopped here to take some shots is I found these interesting rock layers here. Now they're running at an angle there, but actually, if you look here, they've been tilted, and you can tell that because of the horizontal layering, and that indicates they were flat at one point because that's when they formed, but then they were tilted. So if you just look closely, you can tell that. As you can see here, we have a giant boulder that has fallen down the mountain, and it just shows the sheer power of what happens when a big boulder falls down a mountain. As you can see, there's scarring of the topography here as it's traveled down the mountain. Quite remarkable. Now looky here, look what we got here. Can you guess what this is? This is a fault. It's bigger than a joint. It's definitely a fault. Now this is a normal fault because you can tell that the foot wall is to the left and the hanging wall is on the right. The hanging wall on the right is lower than the foot wall on the left. And it dissects down there at a pretty steep angle, but 45-degree angles, give or take. But yeah, that's another good feature to acknowledge in this canyon. Now this is an interesting specimen. It is known as Manzanite, and you can see by its colors it's quite magnificent. The colors basically indicate different minerals, and each the light minerals, the lighter colors from pale, are the oligoclase, the plagioclase. The more clear are the quartz. You have some that are more clear than others. One's just regular quartz or smoky quartz, or you have others that are smoky quartz. And then you have the darker colors, which are hornblende and micas. Now this rock has tells a story about the area. Basically, this rock formed during a slow cooling process, and that's indicated by the phaneritic size of the crystals. Phaneritic meaning large crystals. And so basically, it just shows that this formed with the uplift of the Colorado Plateau and the forming of the mountains. And this particular specimen rose at Cheyenne Canyon, and over time, weathering and erosion took its toll on the rocks around it, and this one was exposed and fell to the bottom of the canyon. Now, I found many of these scattered around the base of the Cheyenne Canyon, and I'm thinking that the majority of them were formed towards the bottom of the canyon, which makes sense because being this a large crystal rock, it just means that this was formed at depth and then rose and broke off, as many of the other Manzanite specimens on the canyon floor. So we've made it a bit further up the trail here, and at Cheyenne Canyon. In Cheyenne Canyon, this is a pretty cool view. As you can see, this is the grand scope of the canyon here, and you can see how the creek down there meanders down. Now that creek is a sign that is just showing us that, you know, its path is responsible for carving out this great canyon. And you know, you got to think about what processes took place here to form this. And you know, this being in a mountain range, you know, most of it's water related, because this, you know, this creek here, when it gets flowing, it's got some carving power, but at the same time, bedrock is a good insulator against erosion. So it takes quite some time for these things to these types of canyons to be carved out. My guess is, though, is at the first uplift stage. So there is a theory that this was an inland sea at one point. So my guess is that it's possible that, you know, during that time, inland seas got trapped upon the plateau. I mean, it may be somewhere up the canyon here, and as the uplift began to occur, water shed off the plateau and started carving out this canyon. You know, the initial blow was perhaps more water than usual, but then after that, it was just subsequent heavy rainstorms that continued to carve out this canyon. And as you can see, in these rocks, it's mostly, you know, the water can't reach up this high usually, but during, you know, winter season, frost and thawing gets between those joints, and each year pries apart the rock and creates the potential for rock slides or rock falls. You definitely don't want to be underneath one of these guys. And I took a picture earlier of a boulder down the canyon, showing the power of just one boulder going down the hill. You should check that out. Anyways, that's it for this little hike. We're gonna do a lot more. I plan on going up to Red Rocks National Park, possibly the sand dunes. But we got all kinds of things planned out for this trip. See you next post.